Google DeepMind and various other companies and individuals are dropping papers around artificial intelligence, large language models almost on daily basis, and there are heaps of them. Just like LLMs, not every paper is worth reading or giving much attention to. But I couldn't resist but to read through this paper because of this quote, which really caught my eye. If you read through this quote from Michelangelo, the sculpture is already complete within the marble block. Before I start my work, it is already there. I just have to chisel away the superfluous material. How good is that? And this is what this paper is doing. I will try to explain this paper in as simple words as possible without going into any machine learning mumbo jumbo, because I think it really touches upon something profound and which could be beneficial in real life. So this paper introduces Michelangelo, which is a new evaluation framework for assessing the long context reasoning capabilities of large language models. This is inspired by Michelangelo's sculpting philosophy. This framework aims to chisel away irrelevant information, revealing the model's understanding of latent structures within the context. Current evaluation methods focus on retrieval tasks, where models extract specific information from a large context like finding a needle in the haystack, but this does not necessarily demonstrate the model's ability to synthesize information from the entire context. So the solution which this paper is dishing out is called as LSQ, or latent structure queries. LSQ is a unifying framework for creating evaluations that measure a model's ability to identify latent structures within the context, synthesize information from these structures, and then go from there. There are three diagnostic evaluations which are present in Michelangelo. First and foremost is reproduce and order. Reproduce a unique portion of the context while understanding ordering. Sequence modification means understanding a sequence of modifications to a list. And third and final, contextual query, which determines if the answer to a query is contained within the context. Let me try to explain with few of the examples. So here you see that this is a code block. Now what this code block is doing, this is primarily a task where, and it's a latent list task that evaluates a model ability to understand and apply a sequence of Python list operation to produce a resulting list. So it's an initial list definition, and then so the structure of the task I'm talking about. Also you can see it here. So on the basis of the previous code, this is the structure. So there is an initial list definition. There is a sequence of list operations like append, insert, pop, remove, sort, reverse. And then there are some view operations like print, sum, minimum, max, and length. So what model is doing, it is going through complexity levels like 1 relevant operation, 5 relevant operations, and so on and so forth. And then it is doing some filling strategies. As you can see here, which ones are not and which ones are. And then it is just talking about different stuff. And if you look at this example, again, it's sort of a multi-round co-reference resolution or MRCR, as they say. So MRCR evaluates a model's ability to resolve co-reference in a long conversation between a user and a model, where the model must reproduce a specific response, the needle, from a previous request, which is the hay. So in this case, for example, the task structure is quite interesting. We have conversation context where the user requests and model responses on various topics. Then we have randomly placed user requests with distinct topics and writing formats. And then we have the thing that model must reproduce output from the conversation corresponding to a specific request. So the key features here is that we have overlapping formats, topics, and there is a reasoning about ordering and context. So the way it is doing it, it is just doing string similarity measure, which is a sequence matching ratio between model output and correct responses. And there are a lot of other things happening here, and there are various other examples in this paper which I don't want to bore you with. But all in all, real good stuff, where they are just trying to remove all the superfluous extra material and focusing on the task. I will drop the link to this paper in video's description. Let me know what you think about it. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.